Welcome to the Deep Dive. Today, we're going to try to wrap our heads around how Ethereum is planning to scale to over 100,000 transactions per second.
Yeah, that's more than some countries process in a day.
It's mind-boggling. To understand how they plan to pull this off, we're diving into two sources: Vitalik Buterin's blog post outlining the roadmap and a Forbes article summarizing the key points.
It's a pretty ambitious goal, but what's interesting is that Ethereum isn't just aiming for speed, right?
Right.
They're focused on keeping security and decentralization too, like those core values.
Exactly. It's not just about slapping on a bigger engine. They're rethinking the whole system. So to get started, where is Ethereum at right now in terms of scaling?
So right now they're using a roll-up-centric roadmap. It means layer 2 solutions, called roll-ups, handle most transactions,
Okay.
while layer 1, the main Ethereum blockchain, focuses on security and decentralization.
So instead of trying to do everything on the main chain, they're building out this second layer to handle the day-to-day transactions. What's the advantage of that?
Well, think of it like a court system. The courts, or layer 1, uphold the law and protect rights, right? They're the bedrock.
Right.
But they're not designed to handle every single business transaction.
Right.
Businesses, or our layer 2 solutions in this analogy, can operate way more efficiently if they have a solid foundation.
Right. Got it. So they're building on that solid foundation. And has this approach been working? Are we seeing any results?
Yeah, totally. Like the recent EIP 4844 upgrade, it increased data bandwidth, and we're seeing a ton of different layer 2 solutions popping up, each with its own strengths.
Oh, cool. So it's like a diverse ecosystem of solutions, all building on this common foundation.
Exactly.
That brings us to the surge, the next phase in Ethereum's scaling journey. What are the main goals?
So the surge is all about hitting that 100,000 plus TPS target, but also making sure the main chain stays secure and decentralized. They also want to make sure that at least some layer 2s inherit those core Ethereum values, you know? And that all these different layer 2s can work together seamlessly. It's the potential is huge. We're talking about a future where blockchain can be used for like everything, everyday payments to complex financial transactions, all on a global scale.
It sounds almost too good to be true. I imagine there are some major challenges ahead, though, right?
Oh, absolutely. One of the biggest hurdles is the scalability trilemma. It's this idea that it's really tough to have all three: speed, security, and decentralization, you know?
Yeah.
You often have to compromise on one to get the others.
So how is Ethereum tackling this trilemma head on? What are they doing?
Well, they're developing some pretty innovative solutions like data availability sampling, that's DAS,
Okay.
and SNARKs.
Those sound pretty technical. Can you break those down a bit?
Sure. So imagine you need to verify it, like a huge document.
Okay.
But you don't want to read every single page, right?
Right.
With DAS, you can just check little pieces of the document randomly. If those pieces look good and are consistent, you can be pretty confident the whole document's valid.
So instead of downloading and checking the entire document, you just check a few parts.
Exactly.
Got it. What about SNARKs? Where do those fit in?
So SNARKs, or succinct non-interactive arguments of knowledge, take this a step further. They let you verify computations without actually running them. Think of it like someone shows you the answer to a complex math problem, and you can quickly check if it's right without doing all the calculations yourself.
So together, DAS and SNARKs allow Ethereum to process more transactions without compromising security. We're getting closer to that 100,000 TPS goal.
Exactly.
But wait, you mentioned Plasma earlier. How does that play into this?
Oh, right. Plasma is another approach. It moves most of the data off-chain, but users can still safely withdraw their funds.
Hold on, isn't that risky? What if some of that off-chain data goes missing?
That's the clever part. Users get special proofs for their assets, and these proofs let them withdraw their funds even if there are data availability issues. It's like an insurance policy for your crypto.
Okay, so it's like a backup system that ensures you can always access your funds, even if something goes wrong. I like that. So it seems like they're exploring multiple avenues to make this work. Okay, let's dive a little deeper into some of these key technologies.
Yep.
Let's start with DAS. Where's the bottleneck right now?
So currently it's the size of these blobs of data, like how much data can fit in each block.
Okay.
To reach higher TPS, Ethereum's aiming for a medium-term goal of 16 millibit per slot, which is a big jump.
Wow, 16 millibit. That's a significant increase.
Yeah.
How are they going to pull off such a huge jump in data availability?
They're looking at two types of DAS, 1D and 2D.
Okay.
With 1D sampling, you basically divide each block of data into samples, and you just need to check a portion of them to be confident about the whole block.
So it's a way to get a good sense of the data without having to check every single piece.
Right.
You mentioned 2D sampling too. How does that work?
So 2D sampling takes things to the next level. Instead of just sampling points along a line, you're sampling points on a grid, both within and between blocks. It allows for even more efficient verification, especially with big data sets.
So 2D sampling sounds pretty powerful.
Mm.
Is it ready to be implemented?
Not quite yet. It's still early research. There's a lot of work to do to figure out the best way to do it and make sure it's safe.
Cutting edge stuff.
Yeah,
But no matter which type of DAS they choose, the goal is clear, right? More transactions, lower fees, a better user experience.
for sure.
Okay, we've covered DAS. Now let's move on to data compression. How does that fit into this whole puzzle?
Data compression is all about shrinking the size of individual transactions. Every byte counts when you're trying to fit as much as possible onto the blockchain.
Yeah, makes sense. So what are they doing to achieve that? What are some of these techniques?
One is signature aggregation, using BLS signatures.
Okay.
Currently, each transaction needs its own signature, right? But with BLS, you can combine multiple signatures into one. It frees up a ton of space.
So it's like having one super signature that validates a bunch of transactions all at once.
Yeah.
Clever. What else?
They're also looking at replacing long addresses with short pointers.
Okay.
It's like using abbreviations instead of full words. And then there's custom serialization for transaction values, which is like a more compact way to represent the numbers involved in transactions.
It sounds like they're really squeezing every bit of efficiency out of these transactions.
Yeah.
Are there any trade-offs?
Well, of course. Switching to BLS signatures requires changes to the infrastructure. And some of these techniques could make the code a little more complex.
I see. It's always about finding the right balance.
Exactly.
So we've seen how DAS enables Ethereum to process more data, and compression lets us squeeze more info into each block.
Yeah.
But what if we took things a step further and moved some data off-chain entirely? That's where Plasma comes in, right?
Exactly. Even with DAS and compression, we might need even more scalability for certain applications, and that's where Plasma shines.
Okay, let's unpack Plasma. What makes it so special for scaling?
Well, Plasma keeps most of the data off the main blockchain. It only stores summaries on layer 1.
Hold on, isn't that risky? What if that off-chain data disappears?
That's where the clever design comes in. Users get special proofs for their assets, which allow them to withdraw their funds safely, even if there are data availability problems.
Got it. So it's another layer of security for your crypto. But isn't there a similar solution, Validium's? How does Plasma compare?
So Validiums also keep data off-chain. But with Plasma, users have more control, right? They can recover their assets even if the operator goes poof. It's a more robust solution security-wise. And get this, SNARKs can make Plasma even more powerful.
Wait, SNARKs are back. How do they make Plasma better?
They simplify the challenge games, which ensure the integrity of the Plasma system. They also allow Plasma to handle a wider range of assets, not just payments.
So SNARKs are like the secret sauce that makes Plasma even more versatile and secure.
Yeah, pretty much.
It sounds like there's already some interesting work being done in this area.
Oh, definitely. There's a fascinating concept called hybrid Plasma rollups, like IntMax. It combines high scalability with privacy. Imagine a 16 millibit per slot world. This could handle like over 250,000 transactions per second.
Whoa, 250,000 TPS, that's getting close to Visa.
Yeah.
But are there any drawbacks to Plasma?
Yeah, one challenge is that Plasma relies on operators, right? So there's an element of trust involved. Developing a really robust framework for security is going to be super important for wider adoption. But hey, even if Plasma only protects some assets, it's still a massive step forward.
Definitely. So we've seen how data availability sampling, data compression, and Plasma are all working towards this goal of a truly scalable Ethereum. What's next on our deep dive into the surge?
Next, we got to look at how Ethereum plans to make layer 2s totally trustless. Because remember, one of the goals of the surge is to have at least some layer 2s inherit Ethereum's commitment to decentralization. So right now, a lot of rollups use these things called security councils to help keep things running smoothly. They can step in and override the system if something goes wrong, kind of like a safety net.
Right, like training wheels while these layer 2s are still maturing.
Yeah.
But the goal is to eventually get rid of these councils altogether, right?
Exactly. Ethereum has a stage development process for rollups. Stage 2 is like the ultimate goal, you know, where the proof systems are so solid that we don't need security councils at all.
Stage 2 sounds like blockchain utopia,
Mm-hmm.
but how do we get there? What's it going to take to build these super reliable proof systems?
There are two main paths being explored: formal verification and multi-provers.
Intriguing. Let's start with formal verification. What's the idea behind that?
Okay, so formal verification uses mathematical and computational techniques to prove that a system is doing exactly what it's supposed to and nothing else.
Okay.
It's like having a mathematical guarantee that the code is bug-free, like a super rigorous audit.
So it's like having a team of math geniuses double-checking every line of code, making sure everything is perfect.
Yeah, pretty much.
What about multi-provers? How does that approach work?
Imagine you have, like, multiple different proof systems.
Uh-huh.
Each one has its own way of verifying transactions. With multi-provers, you're basically creating a system where all of these different systems have to agree that a transaction is valid before it's accepted.
Oh, I see. So if they all agree, you can be super confident in the transaction. But if they disagree, something's fishy and it needs further investigation. It's a system of checks and balances, right?
Exactly, like a jury system, right?
Yeah.
Each juror has their own perspective, but they all have to agree on a verdict.
Makes sense. But building all these different proof systems, that can't be easy.
It's definitely a challenge. It needs a ton of research and development to make sure each proof system is both secure and efficient.
Right.
And then you also got to design a system that can actually combine the outputs of all these different provers. It's pretty complex stuff.
So we've got all these awesome layer 2 solutions popping up, but they're all kind of in their own little worlds right now.
Mm.
How do we connect them to create a truly unified Ethereum ecosystem?
That's where cross-layer 2 interoperability comes in.
Yeah, the holy grail of a multi-chain future, right? Seamless interactions between all these different blockchains. How easy is it to move assets and data between all these layer 2s today?
Honestly, not as easy as it should be. Right now, users often have to use these centralized bridges or go through a lot of hoops to move things between different layer 2s. It's a pretty fragmented experience, and it can be risky too.
Yeah, it's like traveling between countries with different languages and currencies. Not exactly seamless. But Ethereum is working on solutions for this, right? What are some of the things they're exploring?
One big area is like standardizing addresses and payment requests. Imagine if your wallet just knew how to send a transaction to any layer 2, no matter what specific solution it's using.
Like a universal translator for blockchain transactions. That would be incredible. No more worrying about which chain your assets are on. What else is on the horizon?
They're also working on standardized protocols for cross-chain swaps and gas payments, making it easier to move assets and pay for transaction across different layer 2s. The goal is to make interacting with layer 2s as easy as, sending an email.
Love that analogy. But what about trust? Right now, we often rely on third parties for these cross-chain interactions, and that adds another point of failure, doesn't it? How do we make sure all this stuff is secure and decentralized?
That's where light clients come in. A light client is basically like a slimmed-down version of a blockchain node. It can verify transactions without having to download the whole blockchain.
So like a little blockchain detective on your device, keeping an eye on things.
Exactly. And they're working on bringing that trustless verification to layer 2, so you can verify stuff on any layer 2 without needing to trust a third party.
Like a personal bodyguard for your blockchain transactions.
Right.
I like it. But what about managing all these different layer 2s? It could get pretty messy if this ecosystem takes off.
Totally. That's another thing they're working on with key store wallets. Right now, if you need to update the keys controlling your assets, you have to do it on every layer 2 where you have funds.
Yeah, that sounds like a nightmare.
Right. With Keystore wallets, you could manage all your keys from one place, like on the main Ethereum chain, or even a layer 2. Update once, and the changes are reflected everywhere.
Like a master key for your blockchain house. Much more convenient and secure.
Mm.
But we've been talking a lot about layer 2. What about the main Ethereum blockchain, layer 1? Won't all this activity on top of it lead to congestion?
That's a great point. We can't forget about the foundation. This brings us to the final piece of the Surge puzzle. Scaling execution on layer 1.
Okay, so how do we keep the main chain running smoothly as the layer 2 ecosystem explodes?
The simplest approach would be to just increase the gas limit, which is basically the maximum amount of computation allowed in each block, like widening the highway to handle more traffic.
Seems straightforward enough. What's the catch?
Well, increasing the gas limit too much could actually make it harder for people to run their own nodes, which could lead to more centralization.
The scalability trilemma strikes again. Always got to be careful. So what are the alternatives? How can we scale layer 1 without sacrificing decentralization?
One thing they're looking at is various optimizations to the Ethereum virtual machine, the EVM, to make it more efficient.
Okay, getting a bit technical now. Can you give us an example of what kind of optimizations?
Sure. One is EOF bytecode. It's a way to represent the code on the EVM that's more efficient and easier to analyze. It could lead to faster execution times.
So it's like rewriting the instruction manual for the EVM, making it more concise and user-friendly.
Yeah, kinda.
Any other tricks up their sleeve?
Another idea is multidimensional gas pricing. So instead of charging the same price for all types of computation, you charge different prices depending on how resource intensive they are.
Like different toll booths for different types of vehicles? Makes sense. What else?
They're also looking at reducing the gas costs for specific operations that are currently kind of overpriced. Like simple addition costs the same as multiplication, even though it uses way fewer resources.
So they're finding the loopholes in the system. I like it. But won't all these tweaks make the EVM more complicated overall?
It's a trade-off for sure. You want it to be efficient, but not too complex for developers to understand. But there's one more radical idea they're exploring: native rollups.
Ooh, okay, what are those? How do they differ from regular rollups?
Imagine creating multiple copies of the EVM that all run in parallel within the Layer 1 blockchain. That's native rollups.
Wow, that's ambitious. So instead of widening the existing highway, we're building entirely new lanes.
Exactly.
So wouldn't that make Layer 1 even more complex?
It would, but it could offer a huge boost in scalability. It's a trade-off they're weighing carefully.
It's like they're playing blockchain Tetris, trying to fit all these pieces together in the most efficient way. So with all these scaling solutions for both Layer 1 and Layer 2, the big question is, where do we draw the line? What should Layer 1 handle, and what should be delegated to Layer 2s?
That's the million-dollar question. Finding the right balance between the two is super important.
Right. We don't want to end up with a Layer 1 that's so powerful and complex that it becomes centralized, defeating the whole purpose of Ethereum.
Exactly. The goal is to have Layer 1 provide the secure, decentralized foundation, and let the Layer 2s handle most of the transactions and provide, like, specialized functionality.
It's like building a well-coordinated team where everyone plays to their strengths.
It's a tough challenge, no easy answers. But by looking at all these different scaling solutions and figuring out the trade-offs, Ethereum is building a path toward a future where blockchain tech can truly achieve its potential.
It's really inspiring to see the amount of work and brain power going into making Ethereum truly scalable.
Yeah, it's pretty remarkable. And it's not just about the tech either, right? It's also about the Ethereum community and how collaborative they are.
Absolutely. So let's do a quick recap of what we've learned today. We started with Ethereum's roll-up-centric vision for scaling. Layer 2s handle most of the transactions, and Layer 1 provides the security. We talked about some pretty groundbreaking technologies like DAS, data compression, and plasma,
Right,
all designed to push those boundaries of scalability.
right.
We even got into the nitty-gritty of how to make Layer 2s totally trustless and how to make sure they can all work together smoothly.
It's pretty wild, the stuff they're working on. Tackling some really tough challenges. They're constantly pushing the limits of what's possible with this technology.
It makes you wonder, what this super-scaled Ethereum will actually look like in real life.
Right. What kind of crazy stuff will we see with 100,000 TPS?
Imagine, instant payments, these huge decentralized apps with millions of users, a whole new wave of blockchain games and stuff. It's pretty mind-blowing.
It really is. It's a chance to think big, To picture a future where this tech can empower people and communities in ways we haven't even thought of yet.
It feels like we're on the edge of something truly new and transformative, and Ethereum's leading the charge.
Totally agree.
And that's a wrap for our deep dive into the future of Ethereum.
Hope you enjoyed the ride.
If you want to learn more about the stuff we talked about today, check out the show notes for all the links. Until next time, keep exploring and keep pushing those boundaries.